imagine this scenario for a second. A customer is on your massive e-commerce site, and they finally hit Buy Now. Behind the scenes, your web server springs into action. It instantly tries to charge their credit card, update your inventory database, print out a physical shipping label, and then finally send them a confirmation email. At first glance, everything seems perfectly fine, right? Just a standard transaction.
But what happens if your email server is temporarily down? Because everything in this specific pipeline is tightly tied together, one broken link means the entire transaction fails. Your customer screen freezes up. They get this giant, frustrating error message. And you? Well, you just lost a massive sale, all over a broken email server. Think about that for a second. How do we actually stop this from happening? Well, the answer is you stop building rigid pipelines and you start building event-driven architectures. Let's break down exactly what that means. In an event-driven architecture, your components literally do not give commands to each other. They don't boss each other around. Instead, they simply announce things. A component just says, hey, an event just happened, and then it immediately goes right back to its own job. This completely decouples your workloads, meaning your components can now scale up and fail completely independently of one another. But to make this magic work, you really need a middleman. You need a publish and subscribe system, which you'll usually hear called PubSub. Look at the contrast here, it's pretty stark. In a traditional system, component A directly tells component B what to do. So if component B is broken, component A crashes right along with it. It's incredibly fragile. But in an event-driven system, those components just announce their events to a pub/middleman. That middleman acts as a buffer between the two. And honestly, this is the resilient magic of event-driven architectures.
All right, let's jump into Section 1, Amazon SNS, the ultimate megaphone. Let's talk about our first heavy hitter in AWS that makes all this happen. Think of Amazon SNS as exactly that, the ultimate megaphone. SNS is a push-based service, and it's designed to instantly blast messages out to multiple receivers at the exact same time. It's kind of like a radio tower. The DJ speaks into the microphone, and that audio is instantly pushed out in every possible direction. That radio tower absolutely does not care if one car is listening or if a million cars are listening. It just broadcasts. Now, without a service like SNS, your web server has to run custom code to individually connect to your database, then your analytics engine, and then your email server one by one. That creates a tightly coupled bottleneck. But here is where people mess up. The trap with SNS is that it just shouts and forgets. It absolutely does not hold onto messages if the receiving system happens to be offline. Think about it. If your car radio is turned off, you miss the song. Let's walk through that order place scenario again, but doing it the right way. Your web server just drops one single message into SNS, order placed, and that's it. The web server's job is literally done in 1 millisecond. SNS then instantly takes over and pushes that message to 5 different back-end microservices in parallel. This is the absolute magic of loose coupling. Your web server doesn't even know those other back-end services exist, which means it can never, ever be slowed down by them. But here is a really crucial question. Where do people completely fail with this in the real world? Well, SNS is amazing for simple, loud broadcasting, but what if your architecture gets complicated? For example, what if you only want the shipping department to get a message if the customer ordered a physical item, but definitely not if they just bought a digital download? Well, SNS simply isn't smart enough to read the message and selectively route it based on complex rules like that. And that brings us to Section 2, Amazon EventBridge, the smart router. EventBridge is our solution for that complex routing. It's a highly intelligent event bus. So instead of just blindly shouting like SNS, EventBridge actually inspects the data inside the event. It filters it based on custom rules that you define, and then it routes it to very specific targets. Think of EventBridge like a massive, fully automated post office. The mail sorter literally looks at the zip code on every single envelope. It filters them out and drops them into the exact right bucket for the exact right delivery driver. What happens if you try to build a system without it? You end up writing hundreds of lines of complex, messy if-then routing logic directly into your application code. And that just creates a fragile mess that breaks every single time you try to update it. Now, I want you to imagine this running in your system. An EC2 server crashes in your environment. Instantly, AWS drops an event into EventBridge. EventBridge reads that event, filters it based on a specific rule you built, and then it automatically triggers an AWS Lambda function to go and reboot the server. Think about that for a second. EventBridge is acting as the central nervous system for your entire AWS account. It's automatically choreographing fixes before a human even notices there was a problem. So, let's slow down and carefully contrast these two, because you need to know when to choose which. You go with Amazon SNS when you need high-throughput, simple pub-sub broadcasting. You just need that dumb megaphone to push one message out to many subscribers instantly. On the flip side, you choose Amazon EventBridge when you need complex, rule-based routing, scheduled events, or when you want to trigger workflows automatically based on exactly what is happening inside your AWS infrastructure.
Moving on to Section 3, the AWS exam trap.
Look, if you are preparing for the AWS Solutions Architect Associate exam right now, do not miss this. It is a classic pitfall. AWS will constantly try to confuse you between Amazon SNS and Amazon SQS. Pay attention to the exact wording. If the exam asks for a publish-subscribe messaging model to push alerts, the answer is always SNS. But if the exam asks you to decouple an architecture by holding or storing messages until a worker is ready to pull them, the answer is the SQS queue. SNS pushes alerts instantly. SQS holds messages safely.
Okay, let's do a fast, punchy recap to really lock this all in. Event-driven architectures decouple your systems so they literally can't break each other. Here are your 3 rapid-fire takeaways. Number 1, both of these services are absolutely critical for building highly available, fault-tolerant cloud environments. Number 2, SNS uses a pub-sub model to instantly push data to subscribers, exactly like a megaphone. And number 3, EventBridge is heavily used to trigger serverless workflows, like AWS Lambda, based on custom rules, acting as your smart router.
And before we wrap up, here is your final warning. Never assume that event-driven means reliable delivery all by itself. If you push an event from SNS and the target server happens to be down, that message is just gone. For true reliability, you often have to combine SNS with SQS to catch and hold that data safely. So think about how you are building your pipelines right now. Are they rigid and fragile, or are they truly decoupled?